Hello and welcome to Tutorial 2, where we will be covering the topic of descriptive statistics. The first and most basic task in handling a dataset is to describe it. Descriptive statistics let us analyze the data, and it is sometimes the most informative type of analysis that can be done. What we will cover in this tutorial is how to produce these descriptive statistics, which reveal to us the central tendency of the data and its variation. Let us begin by describing nominal variables, which are also called categorical variables. This variable has two or more categories, but there is no intrinsic ordering to these categories. It allows you to assign categories, but you cannot clearly order the variables. Gender, astrological sign, and country of birth are all examples of nominal or categorical variables. Let's take the example of the variable zodiac. Let's type codebook zodiac, and we can see that zodiac carries the label of the respondent's astrological sign, and it has 12 unique numeric codes. So, for example, 3 is labeled as Gemini, and 10 is labeled as Capricorn. Alternatively, we can use the tab command, short for tabulate. Type tab and click zodiac from the variable window, and you can see in the results window the frequency distribution of the respondent's astrological signs. The valued labels for each astrological code appears in the leftmost column, with Aries occupying the top row and Pisces at the bottom row of numbers. We can see that we have 4,353 observations, and we have the frequency for each sign. So for Pisces we have 362 observations. This means that they represent 8.32% of the total observations. Finally, you see in the last column a cumulative distribution of all observations. Look at this column more closely, and you can observe the mode. What is the most common astrological sign in the dataset? It is Virgo. Virgo is the mode. And since we can see that there is a great heterogeneity in astrological signs, we can conclude that there is a high level of dispersion. Now we turn to ordinal variables. An ordinal variable is one where there is a clear ordering of the values. However, even though we can order these values from lowest to highest, the spacing between values may not be the same. An example would be educational experience, elementary, high school, university, and postgraduates, or satisfaction with health services on a scale from 1 to 5. We know the ranking of these values, however, the space between each value is not identical. Now we're going to analyze and describe two ordinal level variables. The first has little variation, and the second is more spread out. We're going to look at the variables help poor and help sick. We will first use the tab command. Here's a little trick. If you want to tabulate a number of observations, you can type in tab 1, and it will tab each variable separately. Typing tab alone with two variables will produce a cross tabulation, and we don't want that now. We will be looking at this in tutorial 4. So we type in tab 1, help poor, help sick, and we get two frequency distributions. Let's look at the help poor. Help poor is an ordinal variable, and we can report both the median and the mode. Response agree with both is the most option chosen, so that is the mode. But how about the median? Remember, the median for ordinal or interval variables is the category below which 50% of the cases lie. So we can see that this means between code 2 and agree with both, since more than 50% of the cases fall in or below agree with both, and this is the median. We can also see that the help poor variable has a relatively low degree of dispersion, and both the mode and the median fall within the same category. Let us now compare this dispersion with the help sick variable, and we can see here that the mode and the median are different. The mode is agree with both, but the median is category 2. Next, we will look at interval level variables. Interval level variables represent the most precise level of measurement. These variables tell us the exact quantity of the characteristics being measured, for example, age or income. Tab age, and you see that this is telling us the exact years of age. This type of data can be described more completely. The sum command will give us a summary of the number of observations, the mean, the standard deviation, and the minimum and maximum values. The sktest command gives us information about the skewness and the kurtosis of the distribution. Look here at the value beneath the PR skewness label. If this value is less than 0.05, then what this is telling us that this distribution is significantly skewed. This is important to know if you are deciding which is the best measure of central tendency, which in this case would be the median. Let's go back to the sum command. You can find the command in your review window. Click on it and edit it by adding comma and then type detail. You will see how much more information you have on this variable. As we said, the best measure for central tendency in this case is the median of 46 and not the mean of 47.14, as we found that the distribution was significantly skewed. Now we will learn about obtaining bar charts and histograms. Visual displays can add richness to your descriptive output. For nominal and ordinal variables, a bar chart is most appropriate, and for interval variables, a histogram would be a better choice. Stata's histogram command will produce either a bar chart or a histogram. However, Stata does have a bar chart command as well, which is graph bar, but we will come back to this in tutorial 4. So let's create a graph for the zodiac variable. In the command window, type hist zodiac, comma, d% and press enter. Stata will display a bar chart of the zodiac in the graph window. To edit, click the Start Graph Editor icon on the graph toolbar. There you can edit the graph as you wish. Follow the editing instructions that are provided on page 23 to page 29. And you will get this graph as an outcome. Let us now create a histogram. Type hist age, comma, %. And just like the bar chart, we get the histogram in the graph window. By clicking on the graph editor icon, you can edit your graph to look the way you want it to. And here we see how our histogram can look like. The final thing we will learn in this tutorial is how to obtain case-level information with sort and list. In a large data set, sometimes we are not interested in how a particular respondent answered a particular question, but rather how an entire group of respondents distributed themselves across the response categories of a variable. Before proceeding, let us close GSS 2006 by clicking Clear. And let us open the states dataset. Suppose you want to know which states have the highest restrictions on abortion. If we tab Abort Law, this variable gives us the number of restrictions imposed by each state, from no restrictions to 10 restrictions. What we will do now is to type sort abort law. What Stata will do now is to silently sort the states from low numbers of abortion restrictions to high numbers of abortion restrictions. Now type list state, and you can see from the output that Vermont has no restrictions, and the restrictions keep going up till you reach Kentucky and North Dakota, both of which have 10 restrictions. So you can see that these commands are useful in that they give us specific information on the groups or the states and how they are distributed according to the abort law variable. With this we come to the end of our tutorial 2. In the next tutorial we are going to learn about transforming variables.